Hi everyone, welcome back. I hope you guys watched my last video on the topic of cell pose for instance segmentation, well, with a special focus on segmenting cells, as the name suggests. In this video, we're going to focus on a framework called Detectron2, and it's amazing. It makes the tasks of segmentation and a few other tasks a bit easy for you, and this is not just for cells. As you can see on the screen, it can be for multiple types of scenes, and of course you can also customize it using your own data set, which will be the focus of the next video tutorial. And if you want to be notified of all of these, again, as usual, I request you to hit the subscribe button right now, and while you're there, try to find that little thanks button if you're feeling extra generous. And you may notice that this video number is 329 and there is no continuity to the previous one because I intentionally am inserting some topical videos, like some relevant videos, right next to each other. Since we talked about cell pose in the last video, it makes sense for me to kind of move these Detectron videos right next to them. And then I'll have other videos. Some videos, there's no continuity. So obviously I'll try to make it as easy as possible for you to follow on a weekly basis on a specific topic. Okay, with that long introduction, I think we are very much ready to jump into the topic. Again, this week's topic, I'm going to focus on introducing the concept of Detectron2 to you, and then also briefly talk about what Panoptic segmentation is, and we'll walk through code for installing Detectron2 and also using pre-trained models to segment certain images. And in the next week tutorial, we will pick the topic up by actually walking through the entire process of image segmentation for instance segmentation, which is you start with your data set and annotate it. I'll show you how to annotate it online and then download the annotations as JSON file and place it in your images folder, and then read them and train a model and then segment future images. So this is the entire project. So please stay tuned and do not forget to hit the subscribe button if you want to be notified. Okay, now let's go ahead and jump in. 2.5 minutes later, we are just starting with this video, and I hope you appreciate all the extra stuff that I try to stuff into some of these videos. Okay, now what is Detectron2? It is an open source object detection segmentation framework. Okay, it's not a specific model. It's not like UNet. This is basically, well, UNet is also kind of framework because you can change the encoder to a different encoder, right? So this is a kind of, think of this as a framework, and it's of course developed by Facebook AI Research. So it gives you an API, a set of tools to get certain tasks done. And we'll learn that hopefully by the end of this video, you will be enlightened with that information. Now it's built on top of PyTorch. So this is not TensorFlow, this is a PyTorch implementation. And it provides a unified API interface, like I already mentioned, to perform various tasks. It can be object detection, it can be instance segmentation, Panoptic. There are a few things that you can actually perform. And of course, since this is from Facebook AI Research, they are actively developing this, maintaining it, and adding new stuff. So hopefully this will be not irrelevant in 2, 3, 4, 5 years from now, right? I mean, you know how these models are nowadays. You see a new one, you're like, wow, I love this, and then it becomes old-fashioned. But as long as it does the job, it's okay in my point of view. And of course, it's designed to be flexible and easy to use. And why? Why is that important? Because it puts your focus on performing your rapid research, whatever that research is, or engineering challenge. So you don't think about, okay, let's write PyTorch, let's write like a bunch of classes, and functions to perform certain tasks. No, everything is available, easy, and that's exactly why I'm covering this, because I don't want to go through the entire PyTorch basics and all that. You don't actually need a good knowledge of PyTorch. Of course, you can extend it if you do, but a good knowledge of Python is required. But PyTorch is running in the backend. Of course, what that means is it's powered by GPU, right? So if you have GPU access, it's gonna make your computations faster, and it also works just on CPU. What does it provide? It gives you access to a lot of algorithms. For example, mask-RCNN. I don't know if you watched my mask-RCNN video, but installing it from Matterport, for example, on GitHub, it's a nightmare. It's not easy. It requires a specific version of TensorFlow or whatever. It's working with these independent ones. I hate it. I'm pretty sure most of you don't like working with all of that installation stuff. You would rather work on your data set and get the results. That's exactly what this does. It provides us easy access to mask-R CNN. In fact, that's something that I will be using in the next tutorial anyway. And of course, a few others like RetinaNet and DensePose and a few others. And it also includes model zoo with a few pre-trained models for object detection, instance segmentation, and a few others. And we are going to use one of those models that's available in their model zoo today as our pre-trained model to perform some instance segmentation on a couple of images I just downloaded from Google search. Now, how does it work? I mean, it's not like Detectron. Like I said, it's a framework, right? So you understand that it's a framework. But for instance segmentation, there's a two-stage approach. Again, this is very similar to mask-R CNN because in the first stage, you have a region proposal network. What does it do? It generates a set of candidate regions. What do we mean by candidate regions? Hey, these are the regions where there may be an object that you're looking for. Right, so that it proposes that. And step 2, you can use mask-R CNN. You can also use fast-R CNN. There are a few other networks that you can actually, or models you can use, but I always use mask-R CNN if it's instance segmentation. Why? Because now we want to classify and segment these candidate regions. So step 1, regions. Step 2, actual object segmentation within these candidate regions. So that's exactly how Detectron2. Again, it sounds like mask-R CNN because it kind of is mask-R CNN. Detectron2 makes it easy for us to access that. And just a summary on region proposal network, it's a CNN, it's a convolutional neural network, and it takes the image as input and it gives you the candidates where the objects may be present, and it's trained to predict a score for each region, like how likely that region contains an object. Of course, eventually what you get out of it is it predicts the bounding box for each region, but bounding box itself is not that useful. Right? I mean, if you're trying to segment objects, if you're trying to find these objects, then the step 2 is mask-R CNN. And I've done a video on this topic, so I don't want to spend any more time on this or waste your time. I'll put the link down in the description, or you can just look for video number 283, which is titled "What is mask-R CNN?" Okay, with that information, let's just go ahead and see, is Detectron2 actually worth it? I mean, you have some other thing, like, do you need to consider this? Here is some benchmark test that they have done on a given GPU, right? I mean, the hardware may change, but this is how things compare. Compared to their own Detectron1, why is it called Detectron2? Because it's the second version. So Detectron1, if it is 19 images per second throughput, now Detectron2, you can actually do 62 images per second. So it's much faster compared to other, including Matterport mask-R CNN. This is basically what I was mentioning. To install that Matterport mask-R CNN, it's a freaking nightmare. And it may work, it may not work. Well, it did work a couple of 3-4 years ago, right? I mean, it was state of the art. Now it becomes a bit old. Now you don't have the same TensorFlow. You don't have the same GPUs. So things kind of change all the time. And let's hope Detectron2 kind of keeps up with this time. So I don't have to, worry about, or we don't have to worry about upgrading our hardware, every 2 years or so. Okay, so, and I did look at some references that suggested that Detectron2 to be more accurate, but then the accuracy improvement, for example, I saw Detectron2 showing like an IOU of 78.3 on a specific data set. I think it was Cityscape's data set, and the next closest competition, like I think mask-R CNN was 76. So there is 2% improvement, but that was just one data point. I don't have enough statistics to tell you that Detectron2 is more accurate than others in all scenarios and situations, but I would always use Detectron2 for instance segmentation and also for semantic segmentation because it makes life easy in accessing all types of these architectures. That's it. Okay, now what in the world is Panoptic segmentation? Because when you look at their documentation, it says Panoptic segmentation. We are not really that much, at least I'm not using that term on a day-to-day basis. But think of it as a summation of semantic and instance segmentation. Because semantic segmentation, it tells you, hey, all the blue pixels here represent cars. All the red pixels represent humans. All the green pixels represent like some trees or something, right? In this specific image on the screen. By the way, I borrowed this image from Google search because it makes it easy for me to explain So do a quick Google search on Panoptic segmentation. You'll find this. This is from ResearchGate, someone's publication, and I couldn't find good references for that publication. Apologies if this image belongs to you. And instance segmentation is, it just puts a bounding box around different objects, right? Here's car number 1, car number 2, car number 3, and you have person number 1, person number 2, person number 3. Combine those two, you get panoptic segmentation, where you have individual objects that are fully semantically segmented. So that's what panoptic segmentation, and I really don't see much of a difference. I mean, with mask or CNN, yes, you get the bounding boxes, you also get the semantic regions within those bounding boxes. So in a way, I don't see a reason to introduce a new term, but there you go. If you're reading any papers or any documentation and if they say panoptic segmentation, you know what they mean. It's primarily used in the context of video segmentation, especially if you're doing autonomous driving, and panoptic segmentation is you're segmenting every pixel. It's not just detecting objects, but you're segmenting the entire scene. And of course, you can use Detectron2 to segment, to load a video and segment it, and it's on their documentation page. But let's go through some code and segment some images using pre-trained models. And of course, keep in mind, next tutorial is going to be training your own model using your own custom data, all the way from annotations to segmentation. Okay, let's jump to Google Colab right now. Okay, so here is my notebook, and again, I'm going to share this, so look for the link down below under description, or go ahead and look for 329 on my GitHub page. My handle is just bnsreenu, BNSREENU on GitHub. Okay, let's start with installing the Detectron2 library, and most of this code I borrowed from the tutorials that they have on Detectron2, but then of course customized aspects that I thought were worth customizing to make it easy for you to follow. So installing this is pretty straightforward. Again, Python pip install pyyaml 5.1, and then you're cloning this from Detectron2 library, and just copy and paste this. It should work on Google Colab. And they also, again, follow their documentation if you want to install this on your local IDE. It's pretty straightforward so far, based on what I can tell. Okay, we are done with installing this library. That's pretty fast, as you can see. And now the next step is going down and importing our PyTorch. Of course, we need Torch and Detectron2. And let's also see what type of CUDA version Google is giving me today. So we have NVIDIA CUDA compiler driver and all the other information that's relevant, as you can see, Torch 2.0, CUDA, and so on. Okay, and Detectron2 version is 0.6 right now. Now let's go ahead and import a few libraries. Of course, I'm importing Detectron2 and a few others I commented out because you kind of need them when you're training your custom model, which we'll do next week, but ignore the commented ones, obviously. And we are importing other regular libraries like NumPy, and JSON is required again, probably not here. I don't think I'm reading these custom data sets, but again, I'm leaving this as is. And I'm using CV2 imshow because obviously in the Google Colab notebook, this is the best way to actually visualize your images using CV2. But of course, if you're doing this not on Google Colab, then you can use CV2.imshow. And from Detectron2, I'm using importing Model Zoo because we want to get some models out of there, Model Zoo, and we want to import the default predictor, get config. I'll explain these in a minute. Get config basically helps you in kind of instantiating your config file that you can modify, and we'll do this right away. And visualizer helps us in visualizing our images, and metadata catalog, dataset catalog. I'm not sure if I'll be using these two right now, but again, this is something, once you have a dataset, you can actually extract metadata and dataset information, and these are like shortcuts to getting that information. So let's go ahead and run this cell, and now let's go down and read an image. I've already connected my Google Drive to Notebook just by going here. I hope you know how to do that, and mounting your drive right there. And once you do that, and I placed a street image like with some cars and stuff, and let's go ahead and have a look at it. Again, I'm using OpenCV to read the image. Of course, you can use scikit-image, whatever is convenient, but there you go. This is just a natural scene image, and I'm using this because I know they have pre-trained it on these type of images. So now let's go ahead and use the same image and look at a few different types of models that they have. So they have key point detection, and they have instance segmentation, and they have panoptic segmentation, right? So we're going to look at each of these, and they're pretty simple. First thing first, you need to define a config or instantiate a config file. So I call this config key point, and I'm using this get config method to define that, and then merge from file. So we are going to get this YAML file, which is the pre-trained model right there, and this is the RCNN R50 model right there. Okay, and that's what we are using right there. And then you can define a threshold right here for this model. So of course, the higher the threshold means you better have higher probability for that specific object. So lower threshold, you get more objects, but then you may pick up some of the spurious things as objects. So you need to find a good threshold balance. Normally, I stay between 0.5 to 0.8. That's the range. Most of the time 0.6 to 0.7 for scientific images. I may go down to 0.5 if the complexity of the object segmentation goes higher. Then I may have to bring the threshold lower to detect objects as full objects. Sometimes you may get partial object. Right, so based on the result, you may have to adjust this threshold. But again, for now, let's not worry about it. And where do you get model weights from? So that's the model. Where do you get the weights from? Pretty much the same thing, right? So we have the YAML file, and again, the model zoo provides key points, and they also provide instance segmentation. They also provide panoptic segmentation. So this specific model is from the key points, and that's the model name. And we are going to instantiate our predictor as default predictor using this config key point right there. And now I can use this predictor to predict on new images, and that gives me the outputs. And now from the outputs, now I can actually go ahead and visualize instantiate the visualizer and go ahead and visualize it by drawing the instant predictions using the instances from the outputs. It's pretty straightforward, as you can see, and then we are showing the image. And this block of code, I always copy and paste, right? So I copy and paste down here, I copy and paste later on. Most of the things stay the same. So using it, as you can see, is pretty straightforward. Okay, let's go ahead and run this. And as you probably know, key points are just the specific locations or landmarks in an image that are very distinctive and informative. So when you're doing two image similarity, for example, a common method to do that is by first defining key points in these images and try to match these key points and say, hey, these two key points are matching, so they must be similar images. So I've covered those applications in the past. Go ahead and look at my, the videos in my channel. But I hope you know what key points are. Well, if you don't, you will see right away what key points are. So there is nothing up here when you look at the result in this part of the image. But when I scroll down, you see how for humans, it's actually defining the key points. Hey, this defines the lower part of the leg. That's the upper part of the leg. And this is the torso. And that's the head part, right? So there are different key points that are defined right here. So this is, if you are looking for key point detector, this is a great way. And of course, it's labeling them as person. These are like 100%. Probably it's rounding it from 99 point some percent to 100% right there. But it's practically 100% that these are humans. So it's that accurate right there. So next step, instance segmentation. I'm sure most of you, especially if you are from engineering sciences, you are interested in instance segmentation. So this is what we will be focusing on even in the next tutorial. But again, very similar approach, right? So I instantiated that. I called my config file config instance, and this is the model right there, model structure, mask RCNN. R50, FPN, 3x, YAML. There are a whole bunch of these, and I just picked this. And here I'm setting a threshold of 0.5. You can change this and see how the output looks like. And I'm getting the model from Model Zoo, or the weights from Model Zoo, because you don't just need the model structure. You need to fill the structure with the weights. And these are the weights that I'm using. And again, my predictor outputs and visualizer output and draw everything. Very simple. This is what I'm talking about when it comes to mask RCNN, especially using pre-trained models, installing and all that, extremely easy. Okay, now if you look at the output, obviously now you have a lot more things to see. There are like cars. Of course, it did not do anything to the road, right? I mean, there is no class for roads here. There is nothing like trees. It got trained on a whole bunch of cars, persons. I think it even detected this, even though I don't see where it says what that is. Maybe it mislabeled that as something, or maybe it did not even pick it up. Is there a green box? Oh, I thought this green box around it is something that we put. So yeah, it did not detect that, but it actually, as you can see, even with this partial area, it's 92% sure that it's a car. There's a backpack right here, 58%. So it is pretty amazing. It's doing a great job. Even this person is wearing a backpack. It's 95% sure that it is a backpack, and it's a person right there. Yeah, it's very easy to use pre-trained models. Now, again, stay tuned for next video for training your own model, but let's end this video. Well, not yet, but let's actually look at the Panoptic segmentation. So we looked at instance segmentation up here. So on this image, how does Panoptic look like? And again, this part, I'm not going to go through again. From Cocoa Panoptic segmentation, I'm loading these weights, and I am applying that onto my input image. Of course, it downloaded the weights right there, and there you go. The difference between this instance and the Panoptic is, look how you have the bounding boxes and then the cars inside like colored, because we're using mask RCNN. It actually does this semantic segmentation within this bounding box, but then all the other regions that are left alone. But if you want to find out, for example, what is the area of the pixels covered by the cars versus the area of the pixels covered by humans versus the area covered by road versus trees, then you don't have full information in this image. That's when Panoptic gives you all the information. You have the road down here. It gives you the pavement right here, persons and trees and everything. Yeah. So yeah, that is Panoptic segmentation. Again, I am going to skip through that, and now let's say, okay, what do we know? I mean, now we have a scientific image, right? I mean, let me show you the scientific image. I have in fact, a complicated image, an image with very low quality in terms of signal to noise. As you can see, there's a lot of noise right there. And some of these objects, I mean, this object is different than this one. I believe that is a mitochondria, but this one is alpha granule, or maybe not, but we'll see that in the next tutorial. And this is an individual cell right there. So if that is the case, how does my instance segmentation actually perform? So let's go ahead and segment that image using our instance predictions, and you can see it does an amazing job. Let me zoom out actually. Let's see. It does an amazing job. But I mean, in detecting the objects, you see how it detected this as an individual objects, but it thinks this is a tie. 9%. I don't blame it. It looks like a tie. So if you don't have a context, it does look like a tie. There is something it thinks knife, 5%. It's 98% confident that this is a tie. And this one is a pizza, huh? And that's a hot dog. So you get all kinds of weird crap. Obviously, we haven't, and donut. Now it's making me hungry. We haven't trained this on our custom labels. So of course it's going to give this. And in our next tutorial, let's take these data set and annotate like 5 images for 4 different classes. So we're not just talking about one single class segmentation. Let's attack multiple things in one video. And also we'll see how, if classes overlap, like you have overlapping objects, how this is such an amazing approach, Detectron2, compared to unit, for example, or even mask RCNN. Okay, guys, I think this provides you good information about Detectron2. And again, stay tuned for the next video, and do not forget to hit the subscribe button. Let's meet again in the next tutorial.